This is a second video in the series about the CP68 operating system. In the first video, we went through the process of getting CP68 configured to run on this Motorola 6800 computer with the 5¼ inch disk drive system from Southwest Technical. Today we're just going to jump right in and start using CP68, compare it to the Flex operating system, which was the most widely adopted operating system for the 6800 and 6809 processors. And then also compare it to CP/M, which of course was the standard for the 8080Z80 world. All right, let me go ahead and put these disks in, and we'll get booted. All right, so as we talked about in the previous video, we configured this thing so that it would run with SWTPC without any modifications. So I can boot this with the D command. Let me get a better view here. If you want to watch that original video, put a link to it down in the comments right below this video so you can watch that first video. All right, the boot process of this is kind of slow in comparison to CP/M, just like Flex is, and we'll get more into why that's the case later in this video. First thing you might want to do is do a directory and see what's out on the disk. And just like Flex, just like CP/M, we have 8-character file names, 3-character extensions, that stuck all the way into MS-DOS even. The disk drives are labeled 0, 1, 2, 3, just like with Flex. If I want to look at drive 1, which is the second drive, I can do a dir1. Now, unlike Flex, which had the concept of the work drive and the system drive, which could be pretty handy, or CP/M, which had the default drive, CP68 doesn't have either of those capabilities. Instead, if you don't put a disk drive, it's always drive 0. Any other drive access for any command is going to require explicitly stating the drive number. All right, we have wildcards just like with CP/M and Flex, but it uses the asterisk and question mark technique that's part of CP/M, which gives you a little bit more flexibility than just eliminating characters like Flex did for wildcards. All right, what we see here is a bunch of CMD files, which is just like Flex. CMDs are executable programs on disk that represent most of the commands executable in Flex, or in this case in CP68. And of course in CP/M that was a .com file. However, there is a difference here, and that is only the commands you see here can be executed by simply typing their name in CP68. In Flex, anything with a .cmd could be executed that way, just like anything with a .com could be done that way over in CP/M. These files that you see here are actually known by the operating system, the memory resident part of CP68. It's in a table. And so any of these can be run, frankly, with even a partial name. So I can run the status command. This shows me what devices are assigned to what logical devices are assigned to what physical devices. I can actually get that to run with a shorter version of the name, anything down to 3 characters. As nice as that is, unfortunately, it means you can have nothing that starts with those 3 characters for any other file name you use, because as soon as it gets a 3-character match, it runs with it. For example, stamp will still run the status command. All right, so what's interesting though is that anything else you want to run, let's get this whole thing again, you have to type the full name, including the extensions. So that's assemblers and editors and programs you write, basic, whatever, you're gonna have to type the full name. So for example, I have this hello.exe out there. I started putting the exe on there to help me remember that I have to type it. Even if I rename this to hello.command, okay, now I've made a mistake here and it's gonna gripe at us. I wanna show you something. Okay, format error. It does not like the fact that I use spaces between parameters. I'm very used to that. You have to type hello.exe, comma, hello.command. However, you're allowed to have a space after the rename command. In fact, you have to have a space after the rename command. It won't work with a comma there. However, if you were to run their assembler or their linker, something that's not one of the commands it knows about, then you have to put a comma after the file name. That kind of inconsistency is very confusing. All right, so now I've actually got a program named hello.cmd. But again, it still won't work. Okay, interestingly, this disk error 15 doesn't mean it can't find the file. That's technically a 4. Disk error 15 is a command format error, which is the same command you get here when you just hit return without anything. Or if I type the rename command improperly, I don't know if you remember that. So let's see, hello dot command, and let's say I put the space in there and put it back, it gave me the same format error for this. So this format error and that format error are the same thing, although it chose to express it much more cryptically in the other case. But anyway, so even if it's a command, if it's not one of the ones it knows about, you have to type the full name. All right, so in addition to these runs that it runs from disk, there's a number of memory resident commands. It would be called an intrinsic command in CP/M. For example, the dir command we've been running, that doesn't run from disk. You don't see that here. The rename command we've done, that is an intrinsic or memory resident command as well. Load, we can load a program into memory, so we could load hello.command into memory. That's an intrinsic command, doesn't have to go out to disk. It's now in memory, and I can run to it with another intrinsic command, jump. Now, constants, numeric constants, you have to use the $sign if it's hex, otherwise it's assumed it's decimal. And so now I jumped to 2000 hex, which is where that program runs, and it gives us our hello world. Now it's required in all commands to use $sign for hex, otherwise it's decimal, except for in his assembler, in his linker. There, if you type a $sign, it's an error, and everything's in hex without putting the $sign. So again, a little bit more inconsistency and confusion. All right, the save command that we did in the other video, that is memory resident, which is good, because when that's not memory resident, like in the case of Flex, where it has to come off of disk, it's hard to build a disk from scratch. You got a bit of a chicken and egg problem there because it's not on disk to use, so it's nice to have that memory resident. A command to execute command files, submit, is memory resident as well. That executes a command file, and we'll see an example of that later. And then finally, there's a command to exit out to the monitor, and that was something we had to patch to jump to swap bug. So let me jump back into the warm start address. Okay. So those are the intrinsic commands, as CP/M would call them, or the memory resident commands as they're called here. All right, so let's take a look at some of the commands we have in here. Boot, as we talked about in the previous video, basically is the same thing that's down on sector 0, and it's just jumping to it here, and it cold boots the system from scratch. The init command allows us to format a disk and put the structures on it that CP68 needs to run a disk, so that's essentially like a format command. Assign, this is kind of interesting. So the status command you saw showed a list of logical devices and physical devices. They all use the same names, but if it's on the left, it's a logical device. If on the right, it's a physical device that you're wanting it to use. And this is a lot like CP/M that allowed this. Flex doesn't have this capability. Now, this is only useful to you if the devices he's defined as physical devices happen to be something that's in your system. For the most part, none of these are. It would require updating or patching the operating system. However, his teletype device, his TTY device, is a 6850 UART serial port at IO address 8010, which that matches up with an IO address of 4, a slot number 4 inside the Southwest Technical. So I put a teletype card, a serial card there. So what I could do is use the assign command to assign the logical device line printer to TTY. Okay, so here's another thing that's interesting. A lot of these commands will stay in the command and give you a prompt to allow you to do something else without having to re-execute the program. And you'll see later with pip, that's really, really handy because pip takes so long to run. To exit this, you have to hit escape and then return. Now the escape is echoed to the terminal, so the terminal's seeing an escape sequence, and that's why I guess the CR is printing out. That must be some escape sequence this terminal uses. So I tend to hit another character as well that aborts the escape sequence, and I'll show you that more in a little bit. All right, so stat will now see that line printer is assigned to teletype. So now when I use anything that uses the line printer, it will go to the serial port at 8010, which I have hooked to a serial printer. Let me turn this printer on. All right, so the directory command has an option to list to the line printer, and it's the /L. And let's, to keep it short, because I have a very slow printer, let's just take a look at the hello files. World War II teletype for the heck of it. So that shows you an example of how that assign statement works. Now, if you're actually going to use that, you would like to run that assign every time you boot it up. It would be nice to put that in a command file and have it executed at startup like you can do with Flex or CP/M. But unfortunately, CP68 doesn't have any provision for running a command file every time you start the computer. And we'll see that here for another set of commands. Let's see. The set command allows you to set a number of parameters about the console. For example, the backspace character, the tab character, the line delete character, how many lines per page if you wanted a page, those kind of things, exactly like you can in Flex. In fact, I think it's called set in Flex too. However, in Flex, if you type set with no parameters, it showed you what all those parameters were. Here in CP68, there's no way to know what those parameters are. Presently, you can just blindly set them, which I find a little bit confusing. All right, so here we are in another command where we can we stay in a command mode for the set program. So I just usually type escape and then some letter, which aborts the escape sequence as far as this particular terminal is concerned, and then I'm back to my prompt. All right, what else? Security sets this attribute field here. If the attribute is 2, that means it's non-renameable, non-deletable. Attribute of 1 is renameable but not deletable, and attribute of 0 is a normal file, so that's all that's used for. And then these other programs we'll talk about in a minute. Here's the assembler and linker that he provides. It's not technically part of CP68, but he wrote them. We'll look at those in a minute. All right, so the last thing I want to look at is pip. This is a peripheral interchange program. This is the program that allows you to copy files. Same program name was used over on CP/M as well. And for the most part, we'll do exactly what you expect. So we'll say pip, and we'll say, let's do hello2.asm equals hello.asm. All right, so this is going to create a new file called hello2 from hello. Now you notice this direction is from right to left, whereas the rename command was from left to right, which to me is a bit confusing. In Flex, everything was left to right. CP/M, everything was right to left. The rename command actually uses the assignment syntax like you see here. All right, so you see that took quite a while to run. Now let's go ahead and escape this. And if you look at our directory, you see we now have hello2.asm. There it is. Of course, you can also copy between drives. So let's copy hello.asterisk. No, that's not the syntax. It's 1 colon equals. Let's see, where am I? Colon equals 0 colon hello.asterisk. All right, now in CP/M, you didn't have to put the 0, whatever the default drive was. Here you're required to take it. All right, so pip is relatively slow. It's a giant program. We'll explain more about that in the second half of this video. It takes about 8 seconds just to get loaded, and it's not because of a bad implementation of the drivers or anything. So when you're copying with pip, it's going to ask you to confirm every file. If you're doing kind of an ambiguous copy, this thing might be nice, but if you're just copying a whole disk to make a backup or something, you're going to have to sit there and hit yes for every single file, which can be pretty annoying in the end. All right, so that's done. And now if we look over on drive 1, you'll see we have our 2 files that we just copied. All right, now in CP/M, there's a type command to look at any source file or text file. In Flex, it's called list. In CP/M, that's an intrinsic command. In Flex, it's a tiny command and just runs super quick. But there is not one of those in CP68. Instead, he expects you to use pip to do anything related to a device because, like CP/M, pip on this machine can copy between devices and files as well as just between files. And this is actually a nice thing. So if you wanted to type a file, let's say we want to look at the source code, you would just do that. Now the type command or the list command in Flex would already be done by now. But here we're still waiting for pip to load because pip does everything and it's very, very large. And so there's our program. By the way, on this assembler, you'll notice I have form constant bytes all on separate lines. His assembler does not allow you to put multiple values on a form constant byte or a form double byte. It's kind of weird. It's a fairly nice assembler otherwise. It kind of surprises me that it doesn't do that. Now another thing this pip is really cool about though, it actually goes a step beyond CP/M. It can actually do conversion of file types as part of the operation as well. So for example, let's say I wanted to take this executable file and create an S record file out of it. You could do that. You could say hello dot, let's make it the S record file and call it an S19. And you put the type, I want it to be hex, equals hello.command. And this is actually going to convert a binary file into an S record file. Or in our case, where we're wanting to load things through a serial port, let's say from a PC in the modern world, you could actually upload an S record file and have it saved off as a binary file. The only downside in that is that it doesn't give you a start address, so you'd still end up having to use the load and save commands to do that. All right, so I can actually just type more commands here. So here we can actually look at that hello.s19 and not have to wait for pip to load again, that 8-second delay. And there's the S record file name. So that's pretty darn cool. The problem with this pip is that it tried to do everything, and in doing so, it was large. It took a long time just to load it every single time. But then also, you didn't want to make it any bigger, so some of the commands are pretty poor shortcuts in my opinion. For example, let's take a long file, just medium long, because this is a miserable example. We'll copy pip itself, which is 31 sectors long. So I'll say pip, and we'll copy it to drive 1. Oh wait, no, that exists, so it's going to complain. Pip 1 colon, let's call it pip 2 dot command equals, and I have to put the 0 in there, we got to remember that. All right, so the first 8 seconds is spent just loading pip, and then you'll see it go into the copy operation. Remember, we got 31 sectors to go on this. Okay, just created the file, and now here's the copy operation. If you were to count all these annoying back and forths, it's doing it for every single sector. All 31 sectors of this. So there's no buffering going on at all. And this is probably the most inefficient way to copy a file possible. It's simple to write, it's a very small, nice looking loop, but it's very inefficient. And when this thing does an entire disk, it just takes forever. All right, so there's actually 2 ways to copy an entire disk. If you did 1 colon equals and then said 0 colon asterisk, asterisk dot asterisk, that's going to go and it's going to do the copy by copying each file one by one. And so everything will be nicely organized in the most efficient manner possible if you had a newly formatted disk. But it's going to ask you to confirm every single file that you copied like we saw before. The other format is without the asterisk dot asterisk. This right here tells pip that you just want to image the disk. It's going to copy it sector by sector, track by track, ignoring file structure. And in that case, you've got 35 sectors times 18 tracks. It's going to go back and forth 35 times 18 times. Now I've also got this running on a system with 8-inch drives with 26 sectors per track and 77 tracks. And listening to that thing go back and forth for 15 minutes is just unbearable. I'm going to demonstrate here in just a minute that you could have certainly written a backup routine that could do these small disks in way under a minute and be nice and quiet and not bang your disk to death. All right. All right, so I think that's well, now let me show you the assembler real quick here. So to run the assembler, you have to type the whole name and you have to put a comma here, and we'll assemble hello and make hello.obj. And this one's even bigger. This one's 3B sectors long. So the entire time that we wait until we see it ask us for parameters is just loading the assembler. I mean, and to me, this is all fixable, and yet this is the way it was delivered. And the guy's own system was this slow as well. All right, so it's let's do L for a listing and O to generate an object file. The actual assembly doesn't take that long because it's a tiny file. All right, and there's our output. And then you could run the linker. This was originally called link, L-I-N-K, 68, but you can't use that file name on CP68 because there's already a file called link, one of the system commands. So it wouldn't have run as the guy wrote it on his own system, which I thought was interesting. So link 68, I almost left off the exe, comma, and we're doing hello.obj. All right, so here in the linker, it does away with the standard of decimal unless you put a dollar sign in front of it. If I try to type a dollar sign here, it gives me an error, a question mark. So you basically have to do everything in hex here. So 2000, this program is tiny. It doesn't use any bytes. It's asking where you want the common. I don't have any. So anyway, the program only went from 2000 to 2016. And I'm not going to save it, but it just put it into memory. So I can actually just jump to it now. And I do now need to use the dollar sign. Excuse me. And there's our hello world. All right, so that does it for taking a look at the basics of CP68. Lots of inconsistencies. I don't have a basic on here for it. There is a basic he wrote called Struble, Structured Basic Language. And it was actually a compiled basic, and a little more towards modern basics where you can use labels instead of line numbers. There was a review written for it in an early Flex newsletter by somebody that actually knew Jack Hemingway and was trying to be nice. He says, but I just can't. This is slow. Excuse me. Basically, it was no faster than most of the interpreted basics that were out there. And it was just a total memory hog in terms of what it could do. And it was difficult to get the linker to run because it was linked in the middle of memory space as opposed to somewhere out of the way. And so you couldn't write a very big program because it had to avoid the linker. Just several problems along lines like that. So in the end, it was not a very good distribution, even with the utilities he offered. But when you look at Flex or CPM, of course, all sorts of people provided other assembler options, other languages, word processing, spreadsheets, those kind of things. None of that was available for a CP68 system other than what the author wrote. And those were mediocre with some inconsistencies. And as long as this video's got, I think I'm going to have to spread it out to one more video to talk about the structure and the internals of how all this worked and why it was a bit on the inefficient side.